Hello and welcome to another video in this series as we learn the basics of Prolog together. Today is the second video on metaprogramming. We introduced the topic last time. We just dipped our toes into it. We talked about what metaprogramming is, and we created probably the very simplest meta-interpreter that you could possibly imagine. And we kind of introduced ourselves to the clause built-in Prolog property, which was useful for finding relevant facts or rules in a database and then doing something with that. Today we're going to extend that very simple program and grow our meta-interpreter a little bit. We'll be doing that over a series of 5 videos. So today you can see that we have the very simple facts, but now we've got some additional rules that extend it a little bit. So we've got cat and dog defined as mammal, but we've got a rule that says something is an animal if it's a mammal, and then something is a life form if it's an animal. So you can see there's a kind of a deductive relationship here. So if I have a hierarchy, I can say life form, animal, and then mammal. And we've got 2 examples of those, dog and cat. So that's kind of the world we've created to play with. Just as last time, we're going to pretend that we are the computer, that we are the meta-interpreter, and we're going to set ourselves a query which is animal, if I can spell, animal, dog. We're going to try and prove that, and we're just going to talk through as a mental thought experiment how to do that. So as we've seen many times, the first thing we want to do is find a relevant rule or fact in the database that matches the query, and the first thing we usually look at is a property, and then anything in the brackets that might be a thing rather than a variable. And straight away we can find, well, we can't. We were going to say we find mammal dog, but this is animal, not mammal. So this doesn't match. That's what matched last time when we were trying to prove mammal dog. That was a query. But now we've got something a little bit more interesting. So the basic facts don't match. Moving down, in the same way that Prolog does, we're doing a search using clause, remember? We'd find this rule, which looks promising because the property is animal and our property is animal. And this is a variable here, so it will match anything. So that's relevant. So that's a good one to explore further. Now, just finding this rule doesn't prove this, because we have a body that also needs to be true. Do you remember in a Prolog, the head is true if the body is true. This is true if this is true in that direction. So that's we need to be conscious of that as we try and kind of prove this. So if we want to prove this is true with x is dog, we need to prove this is true with x is dog. So our query has turned into proving animal dog into proving mammal dog. And we've seen this before when we introduced deductive programs and deductive logic, proving things through deduction. That's one of the earlier ones that we did, so if you need a reminder, do go back and have a look. So this query is now turned into this query, and we then have to start our attempt again. So we start again with this query to prove now. So we go through the same steps. We do a search. Can we find that? Yep, we can, and this time it's straightforward. There's a fact in the database that matches mammal dog, so that is true. And if that's true, we can work backwards, we can backtrack, we work backwards and say, okay, if that's true, then this is true, which means this is true, which means our original query is true. So that was just us kind of talking through as a thought experiment how we would do it. And that's a useful thing to do when we're trying to write meta-interpreters, is put ourselves in the shoes of the meta-interpreter. If we were the meta-interpreter, how would we do this? So let's talk a little bit more in terms of code. How would we do this if it wasn't just us kind of talking, just verbally, if we were thinking about using clause? So first we'd use clause, and H would be this query, animal dog, and then B would find this rule, and B would be the body, that mammal X. In fact, it would be dog because we've instantiated the kind of parameter as dog. So that's now the body. And how do we prove that? Well, we kind of have to search for the body now. So we're using clause again. Let me choose a different color. Now we're using clause again with mammal dog B, and this time it will find this one, and B would be the body of that fact, which is always just true, because remember, empty body or true. The reason I've talked through this step by step, even though it seems kind of long-winded, is to point out that we've used clause twice. Clause the first time with animal dog, and clause the second time because the first use of clause gave us a body which was not simply true or false, it was another property, and so our meta-interpreter needs to take that into account. And you can see, looking ahead, that it might be even more complicated, because we might eventually have to prove something that's got 3 levels rather than 2. In fact, there might be many. There might be recursive programs where we might have hundreds of thousands of these chains of deduction. So if we've got the potential for hundreds of thousands of deductive links, it suggests that our prover needs to be recursive. So rather than writing a prover that it handles 2 cases, one where simple facts, like we did last time, another one where one fact, one rule leads to proving. So one rule leads to proving just one fact. We want to make it more generic, so it can handle any level of deduction. And that's what the example code does, so we'll talk through that now. So you can see here, this code is on GitHub. We've got mammal dog, mammal cat as before. We've got those relations listed, animal X, mammal, life form, animal, nothing new there. Our meta-interpreter looks like it was the same as before, but instead of B equals true, asserting B is true for the very simple facts, we now have that fact that B, we need to cope with the fact that B could itself not just be true, but it could be another property. So then we have to prove that. And look, it's recursive. Prove calls prove. So let's talk through with our example. We wanted to prove animal dog. So the first use of prove has animal dog as H. It finds this rule, animal X, mammal X. That means B is not just simply true, because this is not a fact, this is a rule with a body and a head. And this B will be mammal. So we then need to prove B. So we call prove again. this time with mammal X as the query mammal dog. When we then search for mammal dog this time, it'll find the fact, and B is the body of the fact, which is simply true, and then that will complete that short chain of deduction. And as it's doing that, it will write out the rules that it found that were relevant to proving the overall query. So that is quite a powerful step. The code looks simple. The code is short, and this is often the case with Prolog. The code is often very short, but requires a lot of thinking. I've verbally given you an explanation of how this works with the query animal dog, but I suspect, as I needed it myself to kind of go through pen and paper, so I do recommend you look at the blog. The blog for this one has all that listed out, and the writing is more carefully chosen words, so you can kind of work through and follow it through with pencil and paper. So I do recommend doing that. So let's see if this actually works. In fact, before we do that, let's warm up and check the basics. So we always do this, don't we? Just make sure the very basics work. Yep, that works. Mammal dog. Let's do the more interesting one, which was clause. So we know mammal dog returns B as true because it's just a simple fact and the body is just true. Now let's say animal dog. Let's see what happens there. And the body is mammal dog. So remember, that's the relevant rule, this one. And that's why the body, the head matches that and the body is there. If we put a variable in, let's see what that does. Mammal X. So that's useful to kind of know that that's what happens. When it finds animal dog, the body was mammal dog. So let's try mammal dog. Well, that was the first thing we did anyway, didn't we? And that's true. So let's do, we've been holding off for the proof. Let's do prove animal dog. Remember, this requires 2 steps of deduction, and we hope it will print out 2 lines explaining its reasoning. Let's see. This is going to be exciting. Run. I think this is exciting. Our prover, it's only 2 lines, has proved that animal dog is true, and it's printed an explanation. It says animal dog is true because mammal dog is true, and mammal dog is true because it is simply a fact. That is quite powerful. I think you can probably appreciate that all of this meta-interpreter is quite small, the program is quite small. The ability to print out an explanation for a proof is quite something. So I think that's quite a powerful moment in our learning. This is you're starting to see the power of metaprogramming now, and again, Prolog has made it easy. We haven't got lots and lots of code. We've used very simple elements that we are familiar with now. Let's see if it works for cat as it should. Yep, animal cat is true because mammal cat is true, and mammal cat is true because it's just a fact. Let's try something that shouldn't be true. Let's try fish. Well, it's just false. So it's not printing out any explanations because none of the rules were relevant. You might find in some of the textbooks more advanced uses of meta-interpreters to prove why something wasn't true. That's a much more difficult thing to do. What we want to do here is establish the principles and the concepts, so that if you're interested in that, you learn the concepts here and then tackle that more interesting problem later. You might have noticed that actually our prove program now has 2 lines So it wasn't just prove, it's got something ahead of it when you're using the cut. So that's intriguing. So why is that there? Why did we need a line for proving true? Because previously we didn't need it in a previous iteration of this interpreter. Here we're saying true. If you want to prove true, it's just true, and there's a cut to stop some kind of backtracking. What happens if we don't have that there? Let's see what happens with proving animal dog. So what we're seeing here is an error from the online version of SWI Prolog, which tries to stop you from doing naughty things. So that's not particularly helpful. A better explanation is to think about what proving true does. So when we have a simple fact, mammal, dog, and when we have mammal dog, the clause is mammal dog and the body is just true. So we try and prove true. Proving true, we'll try and find a clause with the head true, and we don't want to do that because that doesn't make sense. True is just true. So we want to catch it here and stop any. So we want to say, if you're trying to prove true, it is just true, and don't do any backtracking, because then if we didn't have the cut, it would then match this and continue again. So if we leave out the cut like that, you can see that's problematic as well. There, you see it backtracked and then tried to continue. So it found it to be true, it backtracked and then ran into problems trying to prove true. So your own interpreter for your own implementation of Prolog may not have a problem doing this, but actually I'm really pleased that the online version does try to stop you doing naughty things, because it makes us write better, cleaner code that doesn't have kind of bad practices. So it's good that it doesn't like trying to prove true. So proving true, we have to say, we have to assert that it's just true, and we don't want you to backtrack and match this as well. So that's the reason that's there. And you'll find that a feature of all our future meta-interpreters have a line which says when you've reached the end of a deductive chain and the last thing you want to prove is just true, it's kind of caught by this and ended as true and no more backtracking. So let's run that. Done. Cool. And let's now try lifeform, because that was 3 levels of deduction. So is a dog a lifeform? Remember, in our picture, something is a lifeform if it's an animal, it's an animal if it's a mammal, and a dog is a mammal. So there's 3 levels there. So let's see if our meta-interpreter prints out an explanation with hopefully 3 lines of explanation. Let's run that. Yep, magic. I think this is really exciting. This is, you can see the start of Prolog being used as a explainer for more complicated answers. I think that's quite a powerful step forward. So let's read this. It says a dog is a life form because it's an animal, because a dog is an animal. It knows that because there's a rule that says that there. How does it know it's an animal? Well, a dog is an animal because a dog is a mammal. That one there. How does it know a dog is a mammal? It's just true because there's a fact that says it's true. So that's quite interesting. That I like that. That's start of something quite powerful. I hope you're excited by it in the same way that I am. We will extend this again next time. We might have an actual recursive program. This isn't recursive, this thing here. Our prover is recursive, but our the program that it's trying to run isn't recursive. We might do that next time. But that's exciting. Brilliant. I hope you've enjoyed that. As I say, Meta-interpreting and metaprogramming can be a little bit of a head stretcher, so do look at the blog if you need a slower kind of explanation. Actually, just before we do finish, I want to do one more thing. I can't let it go, can I? Let's try using variables. So animal X. So we're saying, what are we asking here? We're asking it to prove this query. But this query's got a variable in, so remember with Prolog, when we have a variable in a query, we're not asking if it's true or false, we're asking how it can be true or false. So we're asking Prolog to take this and find out how it can be true, and with our meta interpreter write an explanation as well. So let's try that. It's found a solution, and there's probably more. It's found that x equals dogs works because a dog is an animal, because it's a mammal, and it's a mammal because that's just true. Doing it again, it finds that cat is a solution as well. So this is nice because it's found multiple solutions and explained them as well. Brilliant. I just wanted us to see that how it works with variables. And the magic is our meta interpreter is just that. Not a lot of code at all. So that's the beauty of Prolog. It allows us to write really powerful programs and do some really interesting things that would be really complicated in other languages. Imagine trying to do this in Python or C or Java. It would not be easy at all. But doing it in Prolog, we can start to see the power of Prolog now. I think that's magic. That's fantastic. A small change has allowed us to print out explanations. It's exciting. Right, container enthusiasm. We'll see you next time. Bye.